What we're looking at here is a spot robot, and this is a little bit about the investigation I did to try and find out how I managed to break the joint on the spot robot. Now, what I was troubleshooting at the time was the robot would collapse to the ground for reasons that I did not understand. And that's the position I was trying to get the arm into. I was sending it a move it message, and I was breaking it down into small chunks. That's the arm, and it was the middle joint marked 210 degrees that was the one that actually broke. Here's the break itself. You can see it's an aluminium casting that's snapped. And we'll see another image of it just now. You can see it just sheared straight off, and that was by moving too fast forwards and backwards in a way that I think I understand, but I'm not 100% sure. So this was actually testing previously, just verifying that my joint definitions and things were all correct. So here we are, we're actually checking to see that the angles that we've got there, that -2, 2 degrees, etc., are what I expected, and if it moved the way that I expected it to. Now I have my simulation here, where I've just set that same -2 degrees, 2.4, and we can see that my simulation and the real spot robot both moved in the same direction. So that's a good sign in a way. And this is a broken down long joint trajectory message that's broken down into each individual step. So this part was working. This was working correctly. So you could see that Spot was receiving all the individual long joint trajectory bits of message, and it was moving it to where I expected it to. Now, the stage I was troubleshooting was trying to send it a group of those messages to make it move much more smoothly, so it internally would handle a smoother action by a long joint trajectory message. We'll have a little bit of a look at the code at that in a second. But as you can see, the robot is moving in the same direction, same orientation as in the simulation. There is one small difference, but that was found and explained just with the difference between the move it named commands that I was using on the day that I actually made the video on the left and in my simulation on the right. So now we'll have a look at the code itself. This is the Spot ROS wrapper that was on Spot itself. And what we've got here in the first little bit of it, those lines 950, 951, around 941, 942, they're looking to see if the angles that are being requested are higher or lower than the max or min values, and then it's just changing those if necessary just to the max or min values that have allowed. That was just a check, an error check, just to see if that was where my problem lay. The max new points, that's because the long joint trajectory message in Spot will only take 10 points at once. So we send it 9 new points and 1 repeat of its last position to hopefully deliver a nice smooth action. So moving on to the next part of the code here, what we actually have is the error itself. That's on line 985 there, and that's because I swapped from an if function to a while function. So what that did was the robot went to hard E-stop and dropped to the ground, which is something that's still not 100% understood. But when that happened, it then woke up again, stood up again, and moved the arm. And it had different values and settings because it was trying to look for its arm joint stow position and also looking at this long joint trajectory message. So it went forwards and backwards too quickly. I tried to stop it, but not in time, and the joint broke. So we're not necessarily demonstrating good quality coding here. This was very much work in progress, so there's lots of print statements and in inverted commas silly things within the code that are just checking while I was trying to understand the cause of the robot essentially looking like it had a hard E-stop and dropping to the ground. As you can see there, I've got return true, it worked. Obviously, sadly it didn't. So the next thing that we're going to look at is the actual GUI side of the coding. And what you can see on this is this target movement method. That was sending a specific named position, be it parked or salute or whatever, from the GUI. So you can see that in line 489 to get an actual long joint move it trajectory plan. Once it got that plan, we can see that in line 491, what we sent was that entire plan over to the spot robot, which eventually made its way through to the spot ROS wrapper to decode that message. And we get that from, you can see in line 476 there, testing equals rospy.service proxy. That's calling that service. And then if you look down in line number 496, that's actually calling that and doing that action itself. So sending that move it trajectory message over to Spot for Spot to handle it. Now, unfortunately, also something I noticed in my coding, I was also calling this method Spot Arm Mover method. And what this method was doing was taking the values from the sliders. Now, it is possible that maybe both things were trying to interfere with Spot at the same time. I cannot rule this out, unfortunately, because I'll see that I've got two methods going at the same time. I'm requesting the same arm joint movement move it request that you can see there, line 440. And down at the bottom of the code here, you can see lines 788 and 789 there. I've got this spot arm mover being called. Now, I didn't need that to be called, and I do wonder if that is the cause of my failure, why Spot was dropping to the ground. So the immediate cause, like I say, is the introduction of the while loop, but possibly the root cause is that line 789 there. It was meant to be commented out, I missed it, so that was possibly an expensive mistake on my part. Unfortunately, I don't have the robot to test it, and retesting that might be a bit of a gamble that I don't want to take. But, yeah, there we go, that was my investigation.